Sound check, sound check. Hello world. My name is Stefan Pölz, aka the Flashover, and as you may hear, I have a bit of a cold. I am running on cough drops, so I hope this doesn't get into the way all too much. So today we will continue on building benchmarking types for diagnostic analyzers of Roslyn, which are suggested then to use together with benchmark.net in order to benchmark your Roslyn components, in this case, our diagnostic analyzers. Before I start, I would like to announce that starting with next time, I will be also not only streaming to Twitch, but also to YouTube. This will be a bit of an experiment, doing some multi-streaming. Let's see how this goes. And I would also like to announce, since I am a co-organizer of the .NET meetup in Vienna, if you would like to attend on the 16th of August at our next meetup, where we will be doing lightning talks, but perhaps you not only want to attend, perhaps you also want to give yourself a lightning talk, which is a short talk up to 10 minutes about any topic related to .NET. If you wish to talk, then reach out to the .NET Devs AT, either to me directly or go to our website, netdevs.at. I'll post a link in the description, in the chat. And here is the next event that we will be hosting in Vienna. So it will be an in-person event, but since several years we are also live streaming, so it's always hybrid to Twitch and to YouTube. And let's continue with the follow-up from the last session. We have extended actually a template. Let's jump to the template. Actually, let's have a look at the documentation. This is more revealing. A template which generates a starting point if you would like to build a generator, either an iSource generator with Roslyn 3.8, 3.9, or an incremental generator with Roslyn 4.0, which is included since the .NET 6 SDK. And we extended this to also host a benchmarking project with the component, with the library that we have built in the previous streams that enable both benchmarking of iSource generators and incremental generators. I'm afraid I didn't get around to publish that just yet. I will do so pretty much after this stream and publish and update this NuGet package with the generators. Which includes the benchmarking, but also profiling. We also included a launch setting so that you can, from Visual Studio, profile your generators. And yeah, in this session we will continue building the types for the diagnostic analyzers. So let's go right into it. In here, into the chat, I will post the link to this discussion which yields all the links that we have, all the relevant links, or the most significant links that we've visited throughout building this library. So let's jump into the library. Here it is, f0.codeanalysis.benchmarking. Let's run the tests. We will see some of them fail because since last time, or 2 streams ago, when we started building the benchmarking types for the diagnostic analyzers, I did a bit of refactoring. I wasn't all too happy with the implementation. So I made it more similar to the already existing source generator and incremental generator implementations that we built. So we will see now a test fail because I wanted to have a bit of an entry point of why this is failing and what I've changed. Let me make more space here. Yes. So we had, what we've built is 2 tests, one empty test where we don't pass in anything, we just run the benchmark. And we have a non-empty test where we actually also have we put in some source code and then have some assumptions about it. In this case, since it's an analyzer, we expect a diagnostic out of it. So we pass in a diagnostic and we expect this diagnostic with ID 0, ID 0001, and a couple of other properties that we will go through soon. But in order to build up this benchmark, previously we built the compilation quite manually. So we created an ad hoc workspace. From that, we got the current solution and added projects to that solution and documents to that project. But there is a simpler way by using what we actually do with the source generators as well. So I do have quite some duplication here. I'm still looking into reducing that, but I first want to get it working. So if we have a look at the incremental generator and scroll down to the code where we actually create the compilation, this is pretty much the same, where we have in the source, we will sanitize this source because this source may contain some markup giving information about locations that we will use for the diagnostics. And then we extract the syntax trees, some metadata references, some C# compilation options that we perhaps also want to pass in to the invocation phase of the benchmark. And then, yeah, we create the compilation. So this is pretty much the same code now. I may be able to remove duplication into one single place because it's quite the same. And then all of our benchmarks have 3 phases. We first have the initialization phase where we set everything up. In our case, where we do create the compilation, which is then the input for the analyzer. But also we create the analyzer itself. So we initialize it here. We then put it into an array, an immutable array of analyzers, because this is what the method invoking the analyzers then needs. Which brings us then to the invocation phase, where we actually then from the compilation say with analyzers, pass in these analyzers, which is only a collection of 1 because we benchmark only 1 analyzer at a time. And then perhaps we could reduce some code here, but I wanted to keep that open. So we actually invoke the analyzer here, and then at the end we have an inspection phase where we then make assumptions if our analyzer is actually doing roughly what we expect it to be. It's definitely not as thorough, or it is not intended to be as thorough as proper unit testing, But it should give a bit of a hint if it actually does what we expect it to be, and if this benchmark is actually really meaningful, and perhaps not having some compiler errors and not even analyzing our code for some reason. So we want to assure that the analyzer or the component that we test is actually doing what we expect it is doing. So we then again ask for the analyzers. We get all the diagnostics. Well, not all the diagnostics, but the analyzer diagnostics. We will play about with this method here later as well. And then we hope it is as we expect it to be. So now this test, so we have actually two tests, one which is empty and one we actually have an assumption. And let's see what the error message is. So this is where I left off doing the refactoring. So we see, okay, I missed the category and the title and the description, they're all off. So let's bring them in sync. We have here our test. And here is what we actually produce. Okay, so we have, I actually called this analyzer dash title. And the analyzer dash description, analyzer dash help link. We do get warnings here, but we'll come to them later. What else did I miss? The message, avoid using. Okay. What else are we missing? Okay, the category is off. The message is expecting some ticks, some backticks. No, not backticks, just single apostrophes. The default severity is error, yes. So we assume ticks here. About the category, analyzer category, okay. And about the severity. So in this test, we expect the severity the actual severity to be error, but the default severity should be warning. So let's actually do that. We have the default severity that we set in the actual diagnostic. This is the default severity. This is warning. But when we actually create the diagnostic, we want to override it with a more severe severity. How can we actually do that? We can pass in the diagnostic descriptor, the location, and here the effective severity. So we basically just here have diagnostic severity dot error. So effectively we have error, per default if we have warning if we don't override it here. Now let's run the test. Perhaps let's have again a brief look at what the analyzer actually is doing. So we created an analyzer which should warn about the usage of the keyword dynamic. Well, it's just an example, doesn't mean that you shouldn't use dynamic. There's definitely use cases for that. It does have its performance implications, but there's definitely use cases for it. This is just an example of what quickly came to my mind. It doesn't mean to belittle dynamic in any meaning. So the test is still failing. Let's see. The message. Okay, so there is a mistake. I'm not passing in the method name, but the error here. So the severity did not work. So this overload seems to be wrong. Yes. effective severity. So we need to invoke this overload with a, perhaps let's copy that. Okay, we need to pass in more as well. But that's good because we're going to need, I want to make use of these anyway. So we need, okay, we do have the descriptor. Here we have the descriptor. Then we here have the, actually, I could enable, what's the shortcut for that? I always forget. To enable the Visual Studio inlines. Oh, not super important right now. Effective severity. Then we pass in additional locations. We have null for now. Then we pass in immutable dictionary the properties. Don't have them for now either. That's a class, yes. So we have properties. We will be using them later, and then the message arguments. Oops, I just meant to remove these. Okay. Now the test should become a little bit more green, but it's, I guess, not super green just yet. We have one error. Yeah, I had this error last time as well. The location is off, but this is because I made a mistake, not because the code is something wrong. That's because I am actually passing in the, as a location, the symbol, which is the parameter, but I'm expecting the keyword to fail. But I guess the parameter symbol has a type, and perhaps we could use the location of this type. Well, we could also assume, we could say debug.assert. In our case, we could assume, hold on. I'm actually not doing that just yet. Perhaps I should, well, I just realized what if another method which has a string as a parameter. So we overload it with string, but still, let's call it, no, let's leave it like that. So with a string, we can just return because it's a string returning method. And we shouldn't warn here, we should only warn about dynamic. So I would expect now this test to complain about, I'm expecting one diagnostic, but it's actually 2. Copying this again, and we see unexpected number of diagnostics. So we have this error 2 times, although we only expected it to be there once. So we should actually guard that the symbol dot type is dynamic. How can we check that? There is some special kind. There is a special type. If the special type is, okay, dynamic is not a special type. Let's debug into it and let's see if this could help us. Yeah, dynamic is not really a type because it's compiled to something totally else. This is the string, okay. This should be now the dynamic, yes. And kind is dynamic type. Perhaps this could be our check here. What else could we use? Let's see if the kind is dynamic type. Close. It doesn't want to close. Yes, just took some time. Type.is kind. Kind is a symbol kind, which is an enum. So we could compare it to a pattern magic with dynamic type. So if it is a dynamic type, then we actually want to report that diagnostic. Otherwise, we don't. So let's run this test again. We now expect it to have only this one diagnostic, not two diagnostics anymore. If I copy the error message, yeah, we are back to the original error. Now we can get the location right, because we know this is the dynamic. So for the location, perhaps let's actually do it like this. We can say location. And we don't use the symbol, but we use the type of the symbol. First location. Now this could make the test pass. It does not yet. Okay, analyzes through an exception. Sequence contains no elements. So there's AD0001 is returned if there is actually a compiler error. So, but it seems it's not really well, it is some sort of compiler error because the analyzer doesn't work, which is not part of the compilation step. Sequence contains no elements. Test analyzer in line 44. Oh, it doesn't have a location. Oh, because the type has no location. Ah, yes. Because we're now referring to the actual type, not to the... Oops. Not to the dynamic keyword in the source code. Do we perhaps have... We only have the symbol at our hand. And the I parameter symbol, well, that's not a type, okay. Custom modifiers. Well, maybe... Since in here I don't have the... I would need to do a different analysis here. So where we have the actual, not the symbol, but the actual source. So in this case, the parameter declaration syntax, I believe, available, so that we can actually get the location of the dynamic keyword. But for now, let's change that to the entire parameter, because this is not what this is actually about. We just want to get the correct location out of that. And yeah, I need to change that back to use the first location of the symbol. Now this analyzer passes again, but we have a, hope I'm not overlaying there, down there. So we expected to start with, but it started late. Okay, so it only has the parameter keyword. Okay, well, that should do it for now. And now we have something else. The typo namespace could not be found. Oh, I also have a typo. I have a typo here. Namespace, yes. Ooh, that actually brings me to the idea we should also deal with. Perhaps we should deal with analyzer or diagnostics that happen in the original code without our analyzer and the one which actually our analyzer is producing differently. There was one more issue. So I think I have an error in my benchmark. Yes, I'm here expecting empty. This needs to go. So this should turn the test green. Yes, test is green. Before coming to anything else, I want to clean up a little bit. Get rid of some warnings. So let's jump to our benchmark type to do have some warnings here. I initially made everything sync and async. However, since I changed that with the compilation, the create compilation step is now synchronous. So let's get rid of that async version here, actually. It's only that yes, so we initialize synchronously. However, perhaps I want to get rid of this one. Or should we keep it? Users should actually use that. But perhaps we keep it for, should we? No, let's make it, we can always add it later. Addition is not breaking. So I will only have, if we realize later on, hey, this could be useful, then yeah, we can take care of this later. Add it later again. Okay, and the same for the inspection. Let's get rid of the synchronous version as well, because we do have the awaits here. Okay, so now we need to go to our tests and fix these so they are now all async. So we do need to await them, which turns the test into async. So it's async task rather than void. Okay, so configure await makes sense in library code, but it doesn't really make sense in the unit test code here. I think, not sure if XUnit actually, I'm using XUnit, actually has its synchronization context or a scheduler, a task scheduler, which is not the default. But I also don't really want to care about that. So I would like to suppress this warning for the tests, but only for the tests, not for the production code. So how could we do that? Bin containing folder. Let's have a look at the folder structure. So we could either, there is now two possibilities. So we have in our tests folder, we do have a directory.build.props, which is exclusively meant for tests. So we could add it here and say, okay, we also ignore, what was the key, CA 2007. Which should now remove this warning. Yes. Another way would be, I also want to show that, we talked about this in a previous stream with an editor config or with a global actually I want to do this that way. Let me find the document. I don't have this in our linked list yet, do I? No. So let's jump to .NET 6 and code analysis. And there is configuration. So we have two configuration files, either an editor config, but I do like to use the editor config for styling the code, not for configuring analyzers. We could use it, but what I do prefer is to use the global analyzer config. So this is a file which is not necessarily, but by default called global config. It could be called differently, but then we need to actually include it. If it is global config, it is picked up. So we can create that here. Let's create a new text document that we call .globalconfig. Now let me remove the CA here again so that we get back the warning. Yes. Now we can grab that. Okay, what did I do here? We can say when head control dot, we could either, so this warning also has two fixes available, so we configure it false or true, but we can also suppress it. Now there's different means of suppression. We could suppress it via pragma or via an attribute, suppress message attribute. But what I would like to do, we can also configure the severity via that. And this is actually the code which we would use in an editor config file, but we can also put this into the global config file, but without this type here, because the global config file, the editor config is split in sections where you either have, like, if we have a star, it applies to all files or only to C# files, but a global config doesn't have this concept, so we just remove it. But we will add, when you jump to the documentation, there is global option to true. And we basically change now from the CA 207 severity to none, which should now also make this warning go away. So we could also make diagnostics more severe. For example, change a warning into an error. What we can't do is change a compiler error to like a warning. Like if the C# syntax is invalid, we can just suppress it. This doesn't work like that. Okay, cool. So our test should still pass. Now we don't configure await in our test code. There are warnings. Not test. Okay, no tests available there because some of these projects don't have tests yet. But they will be having them in the future. Okay, while the tests are running, I want to confirm that in our production code, if I remove the configure with, since this is library code, it makes sense in library code to have configure with false. If we do get the warning, and we do, so this is still okay. Test started to run. While they are running, let me write another test, a very important test for the benchmark to ensure that in the invocation phase, the analyzer or the component on the test actually invoked as many times as we expect. So that we actually, that there is no caching or something. I had this when I made an error in the source generator, where then actually was only invoked once. So then the entire benchmark didn't really had meaning, because during the invocation phase of benchmark.net, the method on the test or the component on the test is called many times. And if we would then execute the code actually only one, the generator only once, this would, the numbers wouldn't have meaning anymore. So let's have one test, number of invocations, where we create a new benchmark and we accept this analyzer. On the benchmark, we do have the analyzer property, which is of this type, dot, where we could now have something like initializations should be, we start with 0. Let's actually jump to this analyzer. Let's create 2 properties. Let's make them private set. And let's call them initializations and executions. We increment the initializations every time initialize is called, and for the analyze step we increment the executions. And this is static, so we must make this non-static. Okay. Now we can assert that the initialization should be 0 as much as the executions should be 0. If we initialize the benchmark, after initializing the benchmark, it should still be 0. When we invoke, so this is the phase which is called many times, async task. Now it should be 1, both of them. Let's do it one more time. Should be 2. And also let's do in the inspection phase, we call it one more time. So let's assume that we have it now at 3. The previous test run was successful. Let's run only the C# analyzer tests, not all of them. We don't need to run the source generator tests right now. And the numerification fails. Executions to be 1 but found 0. Here, okay. So the analyzer doesn't seem to be invoked as we expect. The execution did not run. The initialization did, so this is okay. But this is not okay. So this is an important test. What am I doing wrong? Do I perhaps even need that? Let's perhaps the simplest maybe is we just say with analyzers. Perhaps let's do nothing and let's see where this leads to. Okay, now this is already not okay. Now let's return the with analyzers, because this is the extension method on the compilation, where we then pass in our diagnostic analyzer array into it, the immutable array, but there is only one, so this will be of length 1. What we also perhaps while at it, we also have the options, but we will take care of these later. Okay, let's add a to-do here. Analyzer options. Now let's run the test. It does fail because the initializations expected to be 1 but found none. So I guess we do need, with analyzers alone, doesn't seem to really run it. With analyzers, so we do need to say compilation with analyzers. We do need to say get analyzer diagnostics async. Let's discard these for now, but now we only get the initialization. The execution is not run again. There's our error message. I hope you can see that. I'm not in the way. It says that, let me put into a text. So it says the execution is expected to be 1 but found 0. Here we were just 0. So this is okay. Here we have actual 0, which means that this is not hit. So this analyze step is not run again, which is bad because this should run multiple times. In our invocation phase of the benchmark, we want to run this many times because this is, this is the code of the analyzer. What am I doing wrong? Perhaps I need to call a different method. Actually, it surprises me because usually with Roslyn everything is immutable. But it seems to somewhere I mutate. I keep some states somewhere so that the subsequent invoke async now doesn't call into. So we do have the compilation. Does this compilation get modified? This would surprise me. What do we need? We do await. So this method doesn't conclude before. Okay, returns diagnostics produced by all analyzers. There is also a get analysis result. Perhaps we should look into this. What's an analysis result? It has the analyzers. It has diagnostic syntax, semantic diagnostics, Additional file diagnostics, compilation diagnostics. That looks good. Let's try this one. That reminds me of the incremental generator, or the generator itself. Let's have a look at the generator that we wrote several sessions ago. We do create our compilation, and with the and we do also create a generator driver. And with that, we can say one generator and update compilation, or just one generators. And we can get the one result. So something with a one result, and now we have a analysis result. Now that sounds promising. Get analysis result without state tracking async. That sounds promising. It sounds very promising. But let's want to briefly have a look what else is there. Maybe I'm missing something. Okay, these are all private. Here are the publics. I'll zoom out a little bit. So we have those four publics. We have get analyzer semantic diagnostics. Okay, which is part of this one analyzer. What's it called? Result that we saw earlier. So I guess this is just helper methods to extract some parts of it, but we can get all of it. Get analysis result. Okay, so the get analysis result looks promising, but here we have a semantic model, some span, so this is only a part of it, I believe. Populating with produced by all analyzers. Okay. What else do we have public in here? Those four get analyzer so only the syntax diagnostics, analysis result, but also some tree. We could have some additional files, so maybe we're gonna need this later. But for now, let's focus on these to here. So because they are internal. Oh no! No! This is. Oh no! It is public. Woohoo! Oh no! But the without state tracking is private. Damn it. If we say, or perhaps, yeah, no, there is nothing here. If we say state tracking, okay, no, those are private. We cannot access these. Damn it. That looked promising. I'm now looking into where this is called actually. So it is called from, okay. So if we use the methods that return an analysis result, we seem to call the without state tracking. But the method that we currently are using calls into get analyzer diagnostic async. So without the without suffix. So this seems to be doing state tracking. But if we get the analysis result, then we don't have stage tracking. So this seems to be very, very promising. So let's get the analysis result here. And instead of get analyzer diagnostics async, we call into get analysis result async. This is public. It has two inputs, cancellation token and, no, it either has a cancellation token or an analyzers. Why can we also pass in analyzers? That I don't understand yet. Okay, so this one uses the analyzers that I guess are part of this compilation with analyzers. But the other one, which takes analyzers, is using these. Okay, so that's the difference. But we want to use these, so we call this overload with the cancellation token. But we set the cancellation token to none. We don't support cancellation for now. configure await false, and this could be it. This could be it. Let's run the test. Let's see where the error is. Still, executions to be 1 but found 0. The without state tracking looked promising. Let me jump in there one more time. It calls in to get as a result without state tracking async. Diagnostic without doing any partial analysis state tracking. What if I pass in the analyzers? Because, not sure. Maybe this changes something. I doubt that though. Doesn't. Still fails at the same line. But perhaps I need to use this result, maybe. So this is now an analysis result. Let's see what the result has in store for us. I'm not looking at the properties, but at the method. Maybe we need to invoke a method in order to now also call the analysis, the analyze method of the, to actually execute the analyzer, not just the initialization. We have two public methods, get all diagnostics. Let's try that. But I don't care about the diagnostics here, just want to run it. So I'm discarding it to, I like to, let's see it first. When I don't care about the result, I like to discard it like here, in order to indicate, okay, this was not just a mistake by ignoring the result or forgetting about the result, about the return type, return value, but actually discarding it, so telling it's basically the same, but just in source now I see, okay, I know this is returning something, but I don't care about it, I discard it explicitly. This also doesn't do the trick. Perhaps I'm just trying around. Still the same error, executions to be 1 but found 0 at this location, yeah. But my test is right, isn't it? Initialization should be 1, 1. And we do increment these here and here. There is no, I doubt that we have some concurrency issue here. But just in case, how can we atomically increment? That's interlocked dot, there's also an immutable interlocked. I did not know there was an immutable interlocked. To have some operations on immutable dictionary and immutable array. Want to have a look at these later, I don't know then. Interlocked dot increment, where we pass in the location as a ref. Okay. So the executions This does not work with a property. Yes. Okay. Let's make this a getter only. I guess I can convert to full property. Convert to full property. So we have these fields, and let's make them read only. I doubt this changes anything. It doesn't. Still at the same line. Okay. Okay, so we do have a compilation. We have the analyzer, pass-ins and options. Then we say, okay, give me all diagnostics. I will debug into it. Maybe this reveals something. But this is actually the most important part, so that in the invocation phase, the analyzer actually gets invoked all the time. F10. Zero diagnostics. It's also not what I would expect. Because it should yield at least one. So there is one analyzer. It's our test analyzer. That's good. There's some telemetry info. So where the analyzer is a key and the value is execution time. That's cool. Simple actions count. Okay, some telemetry on the analysis. But why is it not? Invoke async doesn't really invoke the analyzer. But how do we? Okay. So this seems to. .NET Amsterdam. Thank you very much for following. And you're actually the 50th follower. This is great. This is a milestone I set myself half a year ago. So I'm super happy that you helped me achieve this milestone. Thank you very much, .NET Amsterdam. But I'm a bit stuck here, I'm afraid. Our analyzer, the analyzer is only initialized, but the symbol action that we register here is not invoked. And I'm not sure why it's not. So we do, it's not in the invocation phase. There it is. But actually, we do get diagnostics out of it. So if because we have another test where we invoke and then inspect, and we actually assert this diagnostic, so something is happening. If I would change this to a 2, so there is still a difference between our invocation phase and our inspection phase, I believe. Yes, because now we have that unexpected. So we do. So I could here like benchmark dot analyzer dot executions should be 1. Let's also assume the initializations to be complete. This is not what I would expect now. Initializations to be 1 but found 2. Okay, yes. Because we do invoke... Okay. This actually, we do expect that. We'll get rid of these afterwards again, because this test should be taking care of that. But just for my sanity, I believe. So in the initialization, we don't invoke. In the invocation, we do invoke once, and then the inspection phase, we just invoke one more time. But with storing all the results that we can then assert against. And we have the same issue here. So executions to be 1 but found 2. So it's not executed again, actually. In the inspection phase, we do say compilation with analyzers, just like up here. And okay, then we do something different because we have changed that. Get analysis result async. That looked very promising to me, actually. Executes all analyzers and returns the corresponding analysis result with all diagnostics and telemetry info. This looks good. Do we have some other public field properties or fields that we could set? No, here's only accessing. Let's see, compilation with analyzers dot. What can we do? To enumerable. Get type, get analysis. We could only get the telemetry info, syntax diagnostics, semantic diagnostics, get analyzer diagnostics, compilation diagnostics, all. If we call the get all diagnostics again, where we get the diagnostics here, what will be happening? Which is interesting, the executions, but found 2. How? It's executed twice here already. That's interesting. What's the error here? To be 1 but found 0. I don't understand. Does this make sense? Not really, does it? How can in the test above, when we first invoke, to have an error. Initialize, invoke, inspect. Initialize, invoke, inspect. Because there is nothing to analyze. Perhaps? Maybe that's my mistake. Because there is no source. So let's give in some source code. Let's just have a public class, my class. Let's make a record. Not sure about the language version. Let's do a class, my class, super empty, so that there is something to analyze. Maybe that's the issue. Because, does this make sense? I guess, well, of course it makes sense, but do I understand correctly? If I register a symbol action, but there is no symbol to be found, no parameter actually, then this is never invoked. This does make sense. Because we invoke that, per parameter that we find. Perhaps I should rewrite, use a different, there is also different analysis registrations that we can set, such as a code block action or a syntax tree action, where I believe we get in each and every syntax tree. And okay, but let's call the initialization. So this is not executions actually. So this executions here is wrong. This is I call it parameter symbol. Parameter symbol actions. Okay, yes, this was my, I believe this sounds all right, because how can this analyze, yeah, I just called it analyze, but this is a bit misleading. It's actually analyze symbol, parameter symbol. Because it only analyzes parameter symbol, nothing else. So this, if there is no parameter symbol in the first place, this is never invoked. Okay, that makes sense. Let's now correct the tests. So let's remove that. If we have, so we need at least one parameter action. So we have public void my method, and this my method is also empty, but it takes one string. Or let's do an int parameter. And now we have one thing to invoke. Okay, this could fix my mistake. Yes, it did. Okay, so my test was wrong. I had a wrong assumption. So this explains also why the test up here was failing before. So the initialization is 1, but the parameter symbol is actually 2, because I had 1 before, but I'm actually having 2 parameters here. So I invoke this analysis method once and twice. I adopted this concept differently or wrongly from the source generator, because source generator has or at least how I use source generator so far, you can create a pipeline. One generator could have multiple pipelines, but with this one pipeline, I expected execution. But with analyzers, you can register an action on different symbols or syntaxes or entire trees, and then those get invoked for all of them, or don't get invoked if they are not found. Okay, so I had a wrong concept here, and now expected parameter access with 2 but found 4. Okay, so this actually gets invoked too many times for my taste. But I want to have this test enough. Oops. Why is that? We have 1, 2. This should be only executed 2 times, not 4 times. But we do have parameter simple action to be 2 but found 4. Down here. Ah, yeah, okay. My bad. So this is all right, this is all right, but after the inspection phase, we just run it one more time. That means we initialized it twice, but actually invoked it 4 times. Yeah. Yes, that makes sense. Okay, cool. So now I will get rid of these. Now we cleared that, everything out. Okay, those braces are optional. No, parentheses are optional. I reverted that, so we public void my method int parameter empty. Okay. And perhaps let's make a theory out of that with an inline dager where we pass in the code and we pass in the number of parameters. So I will grab that and say we have 1 parameter here. Then let's make a second test where we have also public void my method with a char overload parameter. But here we have 2, which now means we pass in. So we start with 0. After initializing, we still have 0. Then after invoking, we actually expect the number of initializations is 1. When we invoke it again, the number of initializations is 2. And for the inspection phase, it's 3. But for those parameter symbol actions, we actually now have parameter symbol actions multiplied by 1. For the second time, multiplied by 2. And for the third time, multiplied by 3. So they should all get executed all over again. Let's run that. This should pass. So first the test got discovered, now it gets executed, and it's green. Yes, okay. That's good, we have a great test. And we can, let's see what we can remove. If I remove that, I believe it should fail. So just that what I want to do now is to have the bare minimal code in the invocation phase, because this is what's executed many times. It should do only executing our analyzers, but nothing more, nothing which is not needed to actually get the numbers in the benchmark then, which are as much as user code as possible and as little as the other code. Okay, so we do need that. I'm wondering if we should do the one with the analysis result, or is get all diagnostics async just fine? I mean, this calls into get all diagnostics with state tracking, which calls into, there's an analyzer driver. That's internal. Analyzer driver, that's internal. With source generators, there is a source generator driver, which is actually public. So they now made the driver actually accessible for generators. Oops, now I lost my trail here. I wonder what is executed if we actually... If it's better to... I'm wondering if it's better to call get all diagnostics here, or perhaps use the get analysis result async here. Let's do a bit of a naive comparison. I guess this is nothing really which gives a significant different result. Perhaps we need to benchmark that and then use the faster. Not sure. If I have 10 that, this takes 521 milliseconds. Well, this is doing debugging, so this is definitely not a meaningful result, but perhaps it gives a indication of whether there is a difference or not. 504, okay. So they are comparable. Perhaps I need to do benchmarking with the two, which is actually faster, but for now I will go with the get analysis result. Because I believe we can extract more information out of that. And use this get analysis result async also in the inspection phase. So we do another perhaps we can also do this just one single time. Maybe I can get rid of this. So we have the compilation, but perhaps we can just store the compilation with analyzers. So we compilation with analyzers is that, and we still need to do the options, okay, and then we just invoke this. So we use the same compilation with analyzers compilation with analyzers type. And okay, now the number of invocations are different. Expected 2 but found 1. So the initialization is not called again. But perhaps this is all white. Is this all white or is this not all white? If I would like to benchmark my analyzer, let's have a look at my analyzer. Should this benchmark include the code here? I guess not, because an analyzer is initialized only once, not multiple times. But I did include in the source generator. If we have a look at the source generator test or incremental generator test, we do have a similar test where this is where I got inspired from, where we have the initializations and the executions, and we do have the initialization phase as well. So we include the initialize of the source generator in each and every invocation. So this is always increased. So it would be weird, in my opinion, that if the source generators do include it in subsequent ones, but the analyzer, for example, now would not. This would be not what I would expect. So this seems to be weird if one thing is similar but not doing quite the same as the other thing. Perhaps it makes sense in the analyzer context, or I'm using it for the incremental generator wrong. But for now, I tend to well, it does make sense in the incremental generator, because in the incremental generator, in the initialization phase, we actually set up the pipeline. Okay. I for now do the same. So I include the initialization phase. Actually, I'm not sure. Maybe I just took a wrong assumption or wrong conclusion. So what I'm assuming now is that the initialization is only hit once. So we change this initialization here to a 1, and actually here also to a 1. But the executions of the analyzer itself should be the same. Let's see if I had a correct assumption here. Oh no, I concluded wrongly. Parent assumed to be found 2, but actually found 1. So it's still 1 from the previous. Yeah, so the analyzer doesn't get 1 again. Okay. That means we should, let me revert that. I will revert this here as well. So we do create the compilation with analyzers every time anew. Okay. The analyzer options, I will need to do them later. And okay. Okay. And now I would like to, since we invoke it with get analysis result async, I would also do this down here. So we have some null checks. Then we enrich the diagnostics that the user is expecting with the actual locations that we get from the compilation. Yeah. And now again, we say compilation with analyzers. So this is the same up, should be the same up here. So I'm passing in the options. It should be the very same line it is. And then also call get analysis with diagnostic results async, no cancellation token. So this should be also the same line, but this time we get the analysis result. So we grab the analysis result, and now this result should have the diagnostics that we desire. So I'm actually now for the inspection phase, I say, okay, the diagnostics should equal the result dot get all diagnostics. Excluded analyzers, get diagnostics. Okay, get all diagnostics does combine the syntax diagnostics, semantic diagnostics, additional file diagnostics, and compilation diagnostics. So it gets all of our diagnostics. Yeah. Well, we could perhaps also split them up in our expectation. So we could expect syntax diagnostics and semantic diagnostics and additional file diagnostics and compilation diagnostics. Or we keep it as it is and we have it all, if we go to the test, have it all like in one diagnostics collection that we expect. Perhaps we could split them up. I'll think about that. Split into syntactic diagnostics, semantic diagnostics, additional file diagnostics, and compilation diagnostics. Not sure, but perhaps this makes sense. But I'll keep it for now. I'll think about it. Maybe we come to a use case later on, or we leave it for now and then can always expand it in a future version. Okay. Then we get all the diagnostics. What else does the result yield for us? It has the analyzer, it has the diagnostics. Telemetry info. Yeah, I guess this is it. Okay, cool. And this should now have all our tests returned to green. It does, yes. Okay. So now for these options. I'll have a look at, because I don't know what they do yet. We do have a warning here. In external visible method, it's not validated. Okay. Since we are in tests, we could also exclude this rule. So let's jump to our global config. Let's bring them in order. Here, now set silent. Could also be none. And yeah, what else do we have missing? Diagnostic analyzer attribute. Yeah, we should add that for C#. Cool. No more warnings. Okay, so what do we do with the options? Because with analyzers also takes, so we're using this overload so far, and we could also say compile, either pass analyzer options or compilation with analyzer options. What's a compilation with analyzer options? Well, that has options, also some callbacks, but I guess it's basically the options. We could set concurrent analysis, log analyzer execution time, report suppressed diagnostics. Okay, this may be actually useful. So let's use the compilation with analyzer options. Okay, but we also need to provide callbacks. I don't like to do that. So I'm not exposing that type, but we can expose these if they are helpful. But let's start with the analyzer options for now. And later on it should be use instead. So the options. What do the analyzer options have? They could be empty, and they have additional files and an options provider. This is cool. Okay. Let's have a look at our initialization type. Because in this initialization type, I already have this analyzer config options. And also, so we will add and also additional texts. So this is cool. We will be using these. Okay. So we already have here our options provider. So we can pass in this analyzer config options provider. Yes, and we need the immutable array of additional files. We have these as well. Oh no, that's an immutable array, right? Yes. Okay, so select. Let's see here, .to immutable array. And the options provider should be not nullable. Okay. So in our case, we always should have it. So it doesn't matter if there are none. Okay, no, actually we could do it like this. If this option provider is null, then we use the overload without, otherwise with the options provider. Okay, but now we should also kind of assert this. I'll comment this out for now because I should have written a test before. So let's write a test which also expects some additional files. Let's have in our test, let's also have a context for additional files. Register additional file action. I never did this before. Which is an action that takes an additional file. Okay, so let's call this analyze additional file. Let's create this method. And context. What is the additional file analysis context? It has the additional file, it has options, cancellation, compilation, and we can report. So I guess we need to report that diagnostic on. That means we need a second rule. I call it the additional rule, which is 0002 additional title, additional category, additional. What would be the input? So in our test, let's support an additional file or additional text. And an additional text consists of a path and a text. So let's have my additional file.txt and some text. Oh, it's a collection, isn't it? And some text. My text. And perhaps we just report. Let's just report on everything that we find here. So we say context dot additional file. Additional file is an additional text where we have the path and can say get text. Which returns us with some source text. And okay, maybe no. Let's assume it isn't. And this additional text, this source text, what is that? It has we can get characters. I guess we can toString it. Or maybe, let's see, text dot copy to. Yeah, let's toString it. And let's report on that. So we report the diagnostic. First, we need to create a diagnostic. Not sure how to, because we don't have any, not sure about the location. Okay, how to report a diagnostic on an additional file. I need to do some homework until the next stream. But for now, I will just try to get something work. So we need to create a location. Okay, this is now, I guess, the tricky part, because I never manually created a location so far, I believe. Location.create. Okay. Is there perhaps a from method? No, just a create method. And we have no syntax tree because it's an additional file. It's like anything. It's nothing C# or Visual Basic. So it could be a XML, JSON, text file. So we need to have this one. Okay, the file path is context.initial additional file.path. The text span. I'm not sure about that one. And the position, not sure about that one either. I need to do some homework on these. But let's ignore the location for now. So we create diagnostic with our additional rule and the location, and then report it. Okay. Still need to figure out these, but we just report the diagnostic per additional file, which means since we now have an additional file, we can expect another diagnostic. This is now ID 002. It's the additional category, all additional, and perhaps the message. In the message, we put in the text. So let's have text colon. Then we pass in the text, which would mean we can pass in this text as a message argument, and now expect that text to be, I want to have an error for now, wrong. Let's see where this test is getting us. It should fail because we're not taking care of the options yet because we commented it out. So we do have a failing test. Count of diagnostic does not match the length of the locations. Ah, yes, because this diagnostic doesn't have a markup key. We should. Number 1. So diagnostic 1. Ooh, does this work? Perhaps we need to update the code how we extract the diagnostic locations. But this may be because, okay. Let's include this code now. So now we have analyzer options. Still not. Let's see where this fails. This may be because I haven't really taken care of, yeah. Oh. Okay. Yes, this is something else because we did not add this new rule to the supported diagnostics. Okay. So let's see where this goes now. It fails. I guess because I didn't take care of, or I didn't consider that diagnostics may be occurring in non-source code, but in additional files. I believe this is the error that I'm having here. So our diagnostics count is 2, but we only have 1 location. Because those locations, when we create the compilation, are only considering source text, not the additional files. Okay, so we need to fix that by, which brings me now to the idea. In the beginning of next stream, we will fix this issue because I also have this issue for source generators. This will be the beginning of next stream. How we can report diagnostics, because now it comes together, I guess, a bit. A source generator can also report diagnostics, but we are not considering this anywhere. If we go to a test generator that we're using, so we have here some test generator, we are not reporting on a diagnostic, or actually we are reporting a diagnostic. So we do take care of that already, but we are not reporting a diagnostic from additional file. So we should also do report diagnostic from additional file. We need to take care of that. And then we basically can fix it for both. Or we do it now in the analyzer and then also fix it for the source generator, that we can also report diagnostics from additional files. Okay, but perhaps we can fix that quickly. I'm not considering the additional files here. So let's, for the create compilation, perhaps we can fix it briefly, quickly. also, well, we pass in the context. Okay, that's good. So we have the additional sources, but we don't using additional files. And we also need to parse these. Yeah. It should be an enumerable of string additional files where we from the context get our additional texts, and we also need to select, basically doing the same here. Also need this markup parser here. And okay, so we have source. The first one is the path. Second one is the text, or source in this case. And we have source dot text. Oh, it's that. Yes. And we return the sanitized text, but the original path. Oops. Okay. And we add to our locations. And this sanitizes our, so in our context, we need to, now the additional texts, need to replace these with our new sanitized version. So we say additional files dot to array. No, actually this is not an array, this is a collection, isn't it? I guess we can say new collection. A collection of string. I'm also looking at the time. We have a bit more than 5 minutes left. Collection takes an iList. Or we just, hope I pronounced correctly, Anaphema QQ. Thank you very much for joining. Thank you very much for following. I believe you're follower number 51. Thank you very much. I need an iList. Okay, so we can toList this. This doesn't work because it's an init only property. No. Damn it. Okay, and because we need to replace these texts, maybe they are not sanitized. But neither were these, so we need to keep them. Okay. Yeah, I guess we need to out these additional files as well. So let's return an array of string, which are our path and source of additional files. And we set these additional files. Let's call them here additional texts. To these dot to array. And We have the compilation. Okay, now we also have out additional files, and we will be using, okay, since this needs to be for the analyzer options, actually needs to be an immutable array of additional files. Let's do that. So this is not an array of string path, this is an immutable array. It's an immutable array of additional text. Okay. And those are the additional files. And we will, these additional texts that we have here, we will select. And create a new, I think I called it ad hoc additional text. And the ad hoc additional text gets a path and a text. So this will be add.path and add.source. Okay, and then we say .to immutable array. This is not working because, oh, additional text. No, hold on, that looks promising. Yes, okay. Because of, what's that? Covariance. Contravariance? Because of variance. And we need to explicitly state the base type. Okay. And now we have the additional files. So, okay, let's see. I guess we don't need, yeah. Basically doing what I did before to convert the additional texts to those additional text types, but I'm now also sanitizing them. So basically I can get rid of this and just pass in here. But this doesn't compile because, oh, var, I guess. Yes. We don't be needing this. We do need additional port provider, and we do have this down there. Okay. So let's remove that and let's run the test. This could be good. It's not. Ooh, it is. It is. It is. Yes. So now the difference is, so we expected location 07, but actually had a total different location of this. That's a different one now. Okay, now the locations are off. Something's wrong with the locations. I guess this is order. Because we now have two sources for locations. The text, the source text, the C# text, but also additional file text. And I believe I evaluate the additional file text before I do the C# text. Yes, actually. So let's remove that. Because we do select here. Let's do that here. Test still failing. Okay, count of diagnostic does not match the length of the diagnostics. Because we need to do this here. Now, perhaps. Now I did it too late because here we create this output locations. So I did it one step too late. And now, yes. Now we have one failure. So we have the unexpected diagnostic at number 1. This is our additional file diagnostic. It is ID 22. It has all the correct category and so on. But the message is wrong. Yes, this is what I expected. And the location is, yeah. So it actually at location 07, but we expected 00 because we set default. So let's first fix the message. Yes, this is good. So it looks good. We are now also getting diagnostics for additional files. So I have here my additional file with ID 1, my text. So let's actually expect here also, instead of wrong, the my text. Let's say hello world. And I will use that same hello world string down here. Okay, this should make that pass. The severity, let's do the same thing with the severity. So we do have this default severity, but we will override it. Let's grab this one here as well. So we have, what was the order again? We have the descriptor, location, effective severity. So our effective severity will be diagnostic severity dot, oops, error. We will have some additional locations, or in this case we don't, properties. Okay, so this should make the severity correct. And it does. Here's our error message. The only thing which is off, here's everything good, is here the location. So the expected location is from 0 to 13. No, this is wrong. That's the actual location, but we expect 0, 0. Okay, so this is definitely something I need to do some homework on, about how to reset this location here. Perhaps I can do something brief. We are at 2 hours. I'll try it. Maybe I get it fixed in 1-2 minutes. Otherwise, I will look it up. Then we can continue on the location for a non-source file. So for additional files, we can set start and length. That sounds promising. So let's do new. The start would be 0, and the length would be. But in our case, we pass hello world, so it will be this text, the length of the text, because we report on the entire string. The line position, I'm not sure about that actually. It has a line position start and a line position end, and the line position is character. Okay, perhaps we can do that. So we have new. Then we have a new line position. We start at character 0, and we have a new line position. We end at character dot length, and this does not compile. Oh, I looked up something wrong, so it has a line and a character. Well, for now we only have a single line, but this doesn't support multi-lines. What about multi-line text? I'll do some homework on that. And what I'm also not sure if this is actually 0 based or is it 1 based. But let's see if the test is passing. And it is. Okay, so I guess this is good enough for now. And okay, to wrap it up, what have we achieved today? We have actually fixed the invocation so that it actually gets invoked as many times as we expect. Or I also had an I assumed something wrong here. I also had a conceptual, I misunderstood it. We can also extract diagnostics from additional files. So we have here additional files. This is super cool. And yeah, so for the next session, let's have a look at these. There is more stuff. There is like additional, we can also set additional locations, custom tags, properties. I want to have a look at these. So we're doing custom tags. We will be doing properties that we can set here. And we will also have a look at this location span. Where is it? No, that's not it. Let's jump to the actual analyzer. There it is. So how can we create a location, an arbitrary location basically for an additional file, which is not based on, let's say, because what I did so far is always getting the location of a symbol, so the location object is already there. Just using the correct one. But how do we create our own location correctly? So we'll start with here, create manual location, or create location manually for an additional file. So this will be the number 1, and with the number 2 and 3 we will have a look at the custom tags and properties. And I guess then for the last step of analyzers, before it is somewhat publishable, perhaps we get to finish it next time, I had one more thing in mind. Let's have a look at the benchmark, analyzer benchmark. With the options provider. Yes, we still need to take care of the options as well. Options. So then we have the options provider, and I guess that's it. That's not it, because we still have this to do, the compilation with analyzer options. And this yields some more options. Those options that we already took care of, but also have some booleans: concurrent analysis, log analysis, report, suppressed diagnostics. Perhaps I also leave them out for now, and they can always be added later on. If there is time, we will include it. Otherwise, we will leave it out, and then we can always add it in a future version. But that's done the next steps. First the location, then the last properties on the diagnostics, and then we perhaps review the options. And this would be it. So we could do this in the next session, in the next 2 hours. This seems doable, or at least almost doable. And then we could also publish the next version 0.3.0, which then also includes diagnostic analyzers, which brings us in our journey quite far, at least in the C# journey, because then we have the diagnostic analysis done, or at least almost done, and then we are basically at halftime, and then have 3 C# types left. Cool. And the next version will also include an improvement for those 2, because they will inherit the improvement for allowing to assert diagnostics from additional files. Perhaps this should be my last action to mention this in the changelog already. So we will edit C# types for diagnostic analyzer, and also allow diagnostics in additional files. Allow to inspect diagnostics from additional files. Cool. Now let's have a look at the notes, at the discussion. So we did a follow-up on the last session. I will soon release the new template package, which includes generators, the benchmarking for generators. We continued implementing analyzers. Next time we will most likely finish it. And next time will be in a week from now, same time, almost same place. I will again go on Twitch, but additionally will also stream to YouTube and see how this is going. And with that, I thank you very, very much for staying a while and listening. Really enjoyed it today, although I have a bit of a sore throat. And this was fun. I learned a bit today, improved a bit today, and I hope this was also interesting for you. Thank you very, very much for staying a while and listening, and may Roslyn be with you.